Thanks very much for the invitation to present this talk. Mark has introduced myself. I will just move on. So here is a brief outline of my talk. And I'm hoping that I can weave all these things together so it's not so fragmented. But I think I will just trying to convince you who you are don't need to convince why is ecological forecasting important and what it is. And I will present some case studies, and through the case studies, I'm hoping to give you some learnings we got from it and some conclusion and recommendation. And then I will put a plug-in for the ecological forecasting initiative. So I'd like to acknowledge my co-authors. And this talk is largely based on this review paper we wrote last year. And I especially would like to acknowledge Alistair Hobday, who inspired me to work with him to write this paper. And we worked very closely together and with many of our CSIRO colleagues, but also a couple of collaborators from the Chinese Academy of Science. So we have collected 9 exciting case studies covering 4 areas on fisheries management, aquaculture management, and harmful algal blooms, and risks to iconic habitats or their users. So for each of the area, we have 2 or 3 case studies. So that's where my co-authors come in. They all contributed writing those different case studies. I will not exhaust all the case studies. I thought you can read our paper, and also given the time, I won't be able to do justice to each case. So I will so this is a summary of our case studies, which is in the paper, and I won't go through them exclusively. But I thought what's more interesting is if I give you a few case studies and pull out a few most interesting lessons we got, and then give you an incomplete conclusion and recommendation, and you can read our paper for the complete story. So I will start with this one case study, which is to predict preferred habitat of southern bluefin tuna. Because this case illustrates several key points about ecological forecasting. So what this one does is it's trying to predict where the juvenile tuna will be for the fishing industry. So the fishing industry would go to harvest those juvenile ones about age 3 to 4, and using the pontoons to tow them back and fatten them. And then a few months later, they would harvest them and put them to the market. So they have a need to know where the juvenile tuna will be, so that because it takes time to mobilize the vessels and the towing is very slow. And so since 2013, CSIRO has been making predictions. And what I'm showing you here, is a most recent forecast, which uses better models. So in 2013, the model, the sea surface temperature prediction is based on a 200-kilometer resolution model. Now it's based on much finer resolution. I think I can't remember exactly, 20 kilometer or 10. So you get much finer resolution forecast for the sea surface temperature. So the connection between the habitat and the physical environment is they have the juvenile tuna have a different temperature range for their preference. So if the temperature is at certain time, a certain range, then they would be more likely to aggregate. So and this forecast is an example showing you where the H2 tuna will be and the H3 to 4. So that is the preferred one. And this is live forecast, and there's a website there. And so one example of the usefulness of this forecast is when the warming was delayed, I think it was in 2019, the industry decided to delay their operations instead of sending their boat there waiting for a few months or weeks for the tuna to show up. So that saves a lot of time and energy. But the other environmental benefit is to avoid unnecessary bycatch. So I guess the other point we want to make is, improved models gives better predictions, but also improved observations. So the tagging, more electronic tagging also helps to validate the model and provide information for the model. There is a point to be made about the funding continuity. So, when you get a project to make an ecological forecast and you put all your effort in, then when your project finishes, what do, right? The industry often wants you to continue to provide it, the forecasts, but you have no money. So this is a point we would like to make later on. So here's another case study, which I'm kind of quite familiar with, is to forecasting green tide in the Yellow Sea. And in 2021, in Qingdao, in Shandong province in China, they have a very huge, large-scale green tide invasion, let's call it, which is the largest they've ever seen, which is a surprise to the government, because if you know the story, the source of the green tides, they are coming from aquaculture rafts. And since 2007, this green tide has happened every year, which is related to the explosion of the seaweed farming industry in China. Apparently, from what I heard, Japan lifted the ban on Chinese seaweed import. So, and the studies shown that those rafts that are used to grow seaweed, and when the farmers harvest the seaweed, the green algae on the rafts got cleaned off the rafts and they float in the sea. So you can see some of the numbers. Actually, there was a survey in 2012, approximately 6,500 tons of this Alga prolifera, green floating algae, was released in the coastal waters. And then they found 62.3% floated up to the surface. So some of them went to the bottom, but a lot of them float to the surface. And they have a very high growth rate of about 26.3% per day. So they dominated in the floating algae patches and moved northward. So this is happening south of the Shandong province. And they got dislodged in mid-April to late May. And then in early June, they arrived at the Shandong Peninsula. So this has been well understood, the source, and the government has been investigating in a lot of research observations. Some examples are shown here, and they thought they had a good handle on it now, because they would send boats to intercept those green tides, and they also try to educate farmers not to dispose them into the sea. So actually, before the 2011 explosion of the green tide, it was reducing and it wasn't such a big scale of green tide. And so that was a surprise for the government. And so we have had a collaborative project with Chinese Academy of Science to try to forecast green tides. And this is an example of their model. So they have developed operational ocean forecasting model, a physical model. And for this 2021 green tide, so we actually made a forecast based on satellite data. So this is satellite image of the green tide. So they extracted, leaf area index and converted it to microalgal bloom, and they were able to track them. And then they used this model, numerical model, to forecast how the algae will propagate towards the Shandong province, and produced a 6.5-day, 6.5-day prediction of the trajectory, and was used by the government. So that was a great success. But through this study, we realized that we actually need even better observations and monitoring tools, and better remote sensing algorithms, and the better physical and ecological models to be able to simulate the life cycle of the algae, and to understand the ecological processes. And also we will need an information system, because we made the prediction experimentally, and but who is going to take it and produce operational forecasts every year? So that's a question. I'm going to spend quite some time on this case study, because I feel this one embodies this information system idea very well. So this is based on a paper published by Andy Stephen in 2019. So there are many CSIRO staff involved in this tremendous effort. You will see very soon. So what happened is, this is called the CIMA Austral. So CIMA stands for Integrated Management System for the Aquaculture. That's in Spanish. And then Austral is the region that was being studied, the Patagonian Austral region. And CSIRO was commissioned to develop an operational information system to support the aquaculture industry in Chile. In this area, it's a very long coastline, 80,000 kilometer long coastline, and has many leases producing salmon, but also mussel, seaweed, oysters, abalone. So salmon is the major production in this industry, more than 90%. And it's worth $3.5 billion US. But they have suffered outbreaks of viral infectious disease, this ISA, I think it's called the salmon anemia, and harmful algal blooms. So they have been, so this industry is heavily impacted by crisis. There was a big impact from the strong El Nino in 1967 and 2015-16. But then there's this outbreak of this infectious viral disease, ISA, in 2007. And in 2016 and 17, there is a huge harmful algal bloom, and the economic losses are massive. I think they quoted like an $800 million loss from the harmful algal bloom alone. So CSIRO has devised this approach for this information system. So in the paper we have a similar version, which is not specific to this CIMA Austral one, but basically you would have a bottom layer with data inputs, then the middle layer you would have all these models. So biophysical model, connectivity model, ecological model, farm model, risk models. And then on the top layer, you would produce all these products and services. But the users are only exposed to the top layer. So they don't need to worry about what model you use and what data you got. So in the of course, for the model, the most important ones are the environmental models and the connectivity models. So this is a simulation of Los Lagos area, the 3D model. So you got the model gives you 3D information about temperature, salinity, wind, currents, tides, but also all these biogeochemical parameters. In the bottom panel, you see the dissolved inorganic nitrogen, ammonia, chlorophyll. So these are used by all these other models to produce forecasts. And so this slide just shows you what kind of input you need. So there is wastewater discharge data, data for the river nutrient sediment loads, and then you also need data for calculation of salmon waste load. So all these data collection takes a lot of effort and coordination. Then you have a connectivity model to understand the connectivity between different farms. So this is an example you can see. Yeah. So if you have, this is a high disposal case. So let's say you have a disease from a farm. You want to see how far this will propagate to other farms who will be impacted by this disease outbreak. So on the left is an example of high disposal, and on the right is an example of low disposal. So if you have an outbreak in this farm, then you are in bad luck because it will affect many farms along the way. But if you have an outbreak on this right-hand corner, this farm, then most other farms are not impacted. So this will provide you with decision support tools, so you will know what to do if there is such an event happened. Do you immediately harvest your salmon, or take your loss, or do you don't have to do much and you can keep on going? But so this is the dashboard for this operational information system. It has many information, lots of information. You have data explorer, data exports. I won't go into detail, but you go into each of these tabs and that will give you information about all kinds of things that you're interested in. And you have report. It can generate reports and visualization and give you a quick summary. You can see it on your phone. And you can also have total access if you are expert and you are part of the team, I suppose. So you can have direct access to supercomputing resources, and you can go into all the models to look at things. And also there is specific risk assessment tools developed. So there are qualitative risk assessment level 1, then level 2 is semi-quantitative, and level 3 is quantitative system risk assessment. So it's for different stakeholders. You can go into these different levels to look at what the risks are for your operation. And then this also has a strategic analysis. So this also looked into look into the future, look into a whole system, how healthy they are, and how, what's the trajectory. So you have use all these bioeconomic model, epidemiological growth model, benthic, and there is also a benthic quality index to show you how healthy it is, the environment for your farm. So this is a very quick overview of what it is for this CIMA Austral information system. So the lessons from it is you can use a suite of modeling visualization tools to evaluate tactic to strategic risks. So using those formal risk assessment models, and an effective web-based framework is very useful for stakeholders. The farmers doesn't need to know about models or anything, can just go to the web and look at what information they need to assess how they should run their farms. And I've mentioned there's tools to formally assess risks. So this highlight the kinds of information you can use for management. More importantly, these tools allow the managers and industry to move from reactive crisis management to a proactive, well-planned, well-anchored, and adaptive management. So this is fantastic. So I also want to mention, so I mentioned about project-based and versus long sustained funding. So I want to talk to you about this NOAA's ecological forecasting efforts, which many people are familiar with. So I feel that this is a model that we should adopt and try to make it happen in Australia and in other countries, to have a national agency that's dedicated to ecological forecasting, and the researchers can provide the tools and iteratively work with them to improve forecasting. So they have dedicated forecasts for harmful algal blooms, for hypoxia, for pathogens, and for also forecasting shifts in species and habitats. They have lots of funding as well. And but you can see across the whole country, it's all covered for different regions. They look after different kinds of harmful algal bloom, different kinds of threats to the ecosystem and to human health as well. And they combine data with modeling, computing, and citizenship. Citizen science? To be able to provide timely, consistent, and reliable forecast to the public. So, for example, in Florida, they have this seasonal red algal bloom forecast because that was dominant over there. But then in California, it's more as the cyanobacteria is the threat. So for different regions, they have different focus, but they all have operational forecasts that they can issue to the public and provide stakeholders necessary information. Now I guess, to put a plug in for the ecological forecasting initiative. This initiative, the mission is to solve the challenge of predicting nature, and it's a grassroots consortium aimed at building, supporting interdisciplinary community practice around near-term ecological forecasts. So I haven't talked about the near-term forecast, but I think Alistair made a point in his presentation, another presentation, about if you make a very long-term forecast, nobody is going to use it because it's too far away in the future. You need to provide more timely near-term forecasts so that the industry, the managers, the government can immediately use them. So I hope you all know what ecological forecasting is. And well, I don't need to explain. So anyway, so this is a list of what it is, the eco forecasting initiative around the world. So you can see in the US, that's the oldest one, and but it's springing up in Canada, Oceania, which is what this talk is for, and Europe. So please sign yourself up and be involved. So as I said, I haven't reviewed all the case studies and all the recommendations that's in the paper, but I hope this is a few useful conclusion recommendations for you. I hope I've convinced you ecological forecasting is a great tool for decision makers, and it's an iterative process. So we don't need to wait for the models to be perfect, the observation to be totally complete before we embark on this exercise. And it can continually improve as the modeling and the observation technology improve. We do need to have be aware of funding and the post-delivery maintenance considerations. And when you sign up for a project, think about what the expectation is for when your project finished, and have a negotiation or discussion with the stakeholders upfront about, are they wanting to continue to fund these forecasts into the future, and would they be willing to put into resources, human power? Can we train them to teach them how to do it? And because otherwise you might have some very disappointed stakeholders, but then you also being dragged into some kind of post-delivery work that you are not funded for. So I think we really need a national agency to take ownership for ecological forecasts, so that we can ensure continuous development and long-term delivery. And I hope you can see that operational information system is very powerful. It is very expensive to develop a very comprehensive system such as CIMA Austral, but maybe not every forecast has to be that comprehensive, but still think about to have an information system that easily disseminates the information you wanted to present. And I believe ecological forecasting is a great way to advance science, because you need to improve everything to make your forecasts, to improve your forecast and make it better. And it can support the sustainable development of the ocean, as we can see. So I think I will stop here. Thank you, and I'm happy to take questions. No sound. I can't hear anybody. Is somebody talking?
Chaojiao, maybe I can be your host for questions at the end of the presentation. My apologies for missing the introduction. And Belinda, if you perform that, thank you.
Mark made the introduction.
Thank you, Mark. Thank you, Mark. In the chat, there was a quick question there. If I negotiate my way to the chat, Rod Holden says, yeah, you said that SEMA, the full operational information system, was pretty expensive. Can you explain the number of years and the approximate cost of that one, Chaojiao?
I wonder if there are any SEMA people here who is heavily involved. I'm peripheral, but I think it was $8 million funding. Took perhaps 5 years or 3 years, and involving 10 or 13, 14 maybe CSIRO people, but also people from Chile, their scientists and their engineers. So it's a massive effort, and yeah, but you can see the results are spectacular.
Yeah, and obviously that type of funding was available because salmon aquaculture in that area is such a valuable industry. But then benefits flow to other industries in that area. And that must be the story around the greed tides in the China example you showed there too. It's such a valuable area that that kind of investment is warranted. And so that will be a challenge around Australia, where our marine industries are more dispersed and perhaps less high value in terms of concentrated activity. Thank you. Belinda, please.
Yeah, thanks, Chaojiao. That was really, really interesting and a lot of food for thought. One thing about the SEMA system is just how comprehensive the access for the users was. And you could see that the effort that had gone into developing the forecasts was probably more than equaled by the effort that was gone into developing the interface. I don't know, have you got any comments about the work that was involved in developing that interface? Like how much effort was involved, and how were the stakeholders brought in to help design the system?
Yeah. Mark, do you want to say something? I think it is, I know there is a team of, a whole team dedicated to develop the informatics system. And it was very, very labor intensive. And afterwards to maintain the system as well. But it is very challenging project because, as I mentioned, even the data input was not easy to collect because you have to talk to different agencies, different departments, and different stakeholders, and they are not always very willing to share their data. And but yeah, to pull everything together and to put up into this system and to get the model running, get the input all running. But even to set up the model, I understand was also difficult because we are not familiar with that area. So you need a lot of background information to. I think one of the lessons, informal lessons I heard, is that you actually shouldn't go in to try to set up a model yourself, but you should help local scientists to set up their model, and you provide advice and guidance. So yeah, that would be a more effective way of doing it. I'm not giving you a complete answer. Sorry. Mark, you want to add something?
Well, I think Karen has more involvement in that project, and she's got a hand up, so maybe she can.
Okay. Yeah, I couldn't see all the people. Yeah. Karen.
Can you hear me?
Yes.
Great. I think I think the model, the modeling products were fit for purpose for the tasks that we were asked to do and deliver on, and they certainly built a new capability for CSIRO Chile, which they were able to deploy on several subsequent projects. So I think they had genuine impact in the area. There was a lot of problems with there were some problems with the host institution, Sana Pesca, having the capability to take on ownership and ongoing maintenance of the systems. They had a high turnover of staff, and that combined with the challenges of working internationally, almost 12 hours separate in those time zones, made it very difficult for training and for knowledge transfer. Some of that knowledge transfer has occurred successfully through CSIRO Chile, and I think that's where we've sort of handed over, and we had a successful collaboration with. If you don't mind, I had a separate question that I just wanted to ask you. It was about how you spoke about international initiatives with ecological forecasting. I wondered how what you're proposing fits in with the AquaWatch mission. I may have missed it at the beginning. I had a bit of trouble connecting. Did you speak about the AquaWatch mission?
I didn't talk about AquaWatch mission, Helen.
Yeah. So my understanding is the AquaWatch mission has a mandate to do some forecasting of water quality all around Australia, and I just was wondering if there's some overlap with some of the ideas you were putting forward.
Yeah, thank you. Who is familiar with AquaWatch? Let's look at the audience.
Well, I could just jump in and say, yeah, I think there will be some interesting. It's interesting when the cases that you've given, Chaojiao, are often quite local, right? And that's because of industries, being local. I mean, by local, it might be hundreds of kilometres, but not continental scale or global ecological forecasting problems. AquaWatch is one where it's trying to go continental scale, but maybe I could direct you to a question to say, what examples are there of continental scale or even global scale ecological forecasting, and if there's not, are there possible applications that people could consider?
Is that a question for me, Mark?
Yes.
Well, I don't know about continental scale forecasting, because as I mentioned, NOAA's forecasting, they actually build each system for each state. Yeah. So you can't, I don't think you can have a continental scale forecasting. You can have continental scale physical forecasting, but probably not ecological forecasting. So, I would imagine around Australia, you would have, around GBR, you would have coral bleaching and maybe water quality forecasting. Then around Tasmania, you have Alexandrium harmful algal bloom forecasting. I don't know. There is a southern bluefin tuna forecasting in the southern, the Great Australia Bight, and maybe there could be some forecasting for Western Australia once Tricky Forest has all his leases implemented. I'm not sure about continental scale, Mark.
Yeah, I just wonder if we can, sorry, you go, Alston.
We have examples where people are trying to do chlorophyll forecasting in the ocean at scales of, 5 to 7 days, and I suppose that would be a global ecological forecast of sorts. And I think some of the group in our ecological forecast group are looking at, say, I think they're called something like a greening index, which is something like a landscape measure of forest cover or something like that in deciduous areas, about when that's happening in Europe, at least, I think. Maybe they're continental scale, but they're pretty kind of low in the food chain, which is Chaojiao's point about you need to have the common biological process pretty tightly coupled to the physics before you proliferate to all the different biologies. Anyone? Sorry, back to you, Mark. Riffin.
Well, I just wonder, if you can, if we can imagine those bigger global scale processes, one, maybe they're not quite as relevant locally, but the benefit is it might bring researchers together on a common problem, and so it might have a academic benefit that then can roll out further by going for a global problem. But anyway, that was just sort of a bit of a discussion point. Alistair, back to you as the MC of the questions. Is there anyone else with questions?
No. Thank you then. With that roundup of questions,